Hare Krishna to all the viewers and welcome in this video where today we are going to discuss about the moment of force. We will do some numericals related to the moment of force. We'll try to understand what is clockwise moment and anti-clockwise moment. So let's just straight and get to the numerical part because there are a few numericals which can be tricky, which can be difficult to understand. So I will try my best to explain you all those things in an easy way. Okay. So first we have these two numericals given here. I hope this board is visible to you. I am not 100% sure about the visibility, but these two numericals are given here. Now what we need to do, first we need to know that what is the formula for moment of force. The formula for moment of force is force into perpendicular distance from the point of pivot. Okay. This is the formula for this is the formula for moment of force. Now this moment of force can be clockwise, means in the clockwise direction, it is rotating the body in the clockwise direction, or it can be anti-clockwise, means it is rotating the body in the anti-clockwise direction. Okay. Now we have two numericals here. Let me read the questions first for the numerical. First numerical, the question is the diagram in figure 1.28 means this is the figure which is given here. So the diagram given here shows two forces, F1 equals to 5 Newton, F2 equals to 3 Newton, acting at points A and B of a rod pivoted at point O, such that OA equals to 2 meter and OB equals to 4 meter. So these are the things that we have given. There are two forces, F1 which is 5 Newton, F2 which is 3 Newton. Okay, and then we have the point of pivot O. From the point of pivot O, the distance of F1 is 2 meter, and from the point of pivot O, the distance of F2 is 4 meter. Okay, now what is the question being asked? Calculate the moment of force F1 about O. What will be the moment of force F1 about O? So there the moment of force F1 will be 5 into 2, right? 5 is the force, 2 is the distance. So the moment of force will be 5 into 2 Newton meter, मतलब 10 Newton meter. Next question is the moment of force F2 about O. F2 is 3 Newton, the distance is 4. So the moment of force will be 3 into 4, that is 12 Newton meter. Now we need to know the total moment of two forces about O. So here if you can see the diagram, this F2 is your anti-clockwise. This F2 is your anti-clockwise force, whereas this F1 is your clockwise force. Now there can be some confusion in determining the anti-clockwise and clockwise moment of force, but here this F2 is your anti-clockwise and F1 is your clockwise. Okay. Okay, opposite is true. Sorry, the F1 force is anti-clockwise and F2 force is clockwise. Okay, F2 force is clockwise and F1 is anti-clockwise. So the moment of force for F1 was 10 Newton meter and the moment of force for F2 was 12 Newton meter. Okay, so if you just do the calculation, then for anti-clockwise moment we take positive value. Anti-clockwise moment is taken as positive and the clockwise moment is taken as negative. So if you just do the calculation, you will get the final result as 2 Newton meter, which is in the clockwise direction. Okay, so this is a simple numerical. The only thing with such numericals can be your confusion in clockwise and anti-clockwise moment. Okay, like I got confused in clockwise and anti-clockwise moment. So similarly, you can have also such kind of confusion. So if you practice more, you will be able to clarify this mistakes. Achha. Next question. Let's move on to the next question. Next question is two forces, each of magnitude 10 Newton, act vertically upwards and downwards, respectively at the two ends A and B of a uniform rod of length 4 meter, which is pivoted at its midpoint O, shown in the figure 1.29. Determine the magnitude of resultant moment of force about the point O. So there is a rod which is pivoted at O. The total length of the rod is 4 meter. Okay, and next what happens that there is an upward force of 10 Newton and there is a downward force of 10 Newton. So if you look carefully, this upward force will produce a clockwise moment and this downward force will also produce a clockwise moment. So the total moment of force about this point O will be 10 into 2 plus 10 into 2 Newton meter, that is 40 Newton meter. Okay, 10 into 2 was for the first clockwise moment and then 10 into 2 was for the second clockwise moment. So for this, the total force which is produced, the total moment of force is produced is 40 Newton meter in the clockwise direction. Okay, so these are some very basic numericals, some basic questions that I am trying to help you with. Now there can be other questions as well, like there can be questions based on the meter rule. Okay, so what we will do, we will take one such question based on meter rule and we will see how it goes. So there are multiple questions, but let me take this one. In figure 1.32 shows a uniform meter rule placed on a fulcrum at its midpoint O and having a weight 40 gf at the 10 cm mark and a weight of 20 gf at the 90 cm mark. Is the meter rule in equilibrium? If not, how will the rule turn? How can the rule be brought in equilibrium using an additional weight of 40 gf? Okay. So all these questions are basically from the Selena Concise Physics book. So if you have the book, I think you will get the questions as well. Okay. So let's draw the uniform meter rule. So this is the suppose uniform meter rule which I am trying to draw and explain. Now what is given here is it is pivoted at this point and at this point there is a force of 40 gf and at this point there is a force of 20 gf. This is 10, this is 90. Acha, now try to understand. First question is the meter rule in equilibrium? Okay, so here the force is 40 gf, here the force is 20 gf. The meter rule is, the pivot point is at the center at 50 centimeter. Okay. Now first of all we need to know when a body is in equilibrium. The body is said to be in equilibrium if the total, if the anti-clockwise moment is equal to your clockwise moment. Okay, net clockwise moment is 0, then only the body is said to be in equilibrium. Okay. Now here the question is the meter rule in equilibrium? So the answer is no, because there is a difference in the force. Here the force is 40 gf in the left hand side of the rule and on the right hand side of the rule the force is 20 GF. Okay, now I know that it will be a little bit difficult for you to understand because you may find it difficult to see the board properly, but I will try to make some arrangement to solve this issue. But I wanted to make this video with this arrangement to see how it goes. Okay, so I will try to solve this issue as soon as possible. Okay, so this is 40 GF, this is 20 GF. Obviously, next what happens ki this is the 50 centimeter mark. So from here, this is the 10 centimeter mark. That is the distance between these two is 40. So here the (40 into 40) means 40 GF centimeter is the moment of force, and here it is 40 into 20. (800 GF centimeter). Okay, so both are different. One is 1600 GF centimeter, the other one is 800 GF centimeter. Okay, both are different, so both will be in different directions and both are not equal. Okay, one is anti-clockwise, another one is clockwise. So because of this, what will happen? The body or the scale will turn. It will turn in the anti-clockwise direction because the anti-clockwise force here is more than the clockwise force. Okay, so the body will turn in the anti-clockwise direction. Now what is the next part of the question? The next part of the question is how can the rule be brought into equilibrium by using an additional weight of 40 GF? Now what is the difference between these two moment of forces? The anti-clockwise moment of force was 1600, the clockwise was 800. The difference between the two is 800 GF centimeter. Now we are adding a 40 GF centimeter weight to balance the force. So if we place that 40 GF centimeter plate at a distance of 20 centimeter from the center, 20 centimeter in the right direction from the center, then we can balance the scale and then the body will be in equilibrium. Okay, so total what let's take a look again what happened in this case. There is a uniform meter rule. At one point there is a fulcrum at the center. At one point it is suspended to a 40 GF load, at the other point it is suspended to a 20 GF load. Okay, the distance is 40 centimeter from the point of center, so moment of force will be 40 into 40, and for the other end also the distance is 40 centimeter, so there also the moment of force will be 40 into 20. The difference is 800 GF. If you want to balance using a 40 GF 40 GF weight, we just need to add the weight at a 20 centimeter mark from the 50 centimeter point which is at the center, so we can balance it. Okay, so these are the few numericals that we have discussed today. I hope that you may have understood something. I know it is not the ideal setup to understand all these things, but I am just trying to build this setup. I am trying to improve it. And I hope I will get some better results in the future as well. So for now, thank you. If you have any query, you can ask me in the comment section. Thank you for watching. Stay safe and be happy. Hare Krishna.